Hello, and this is section 3.8. We're almost finished with section 3, and this section is even shorter than the last, and your book basically just takes the time to tell you about counterions. It's what I've been trying to show a little bit in this course, and simply the fact that salts exist. So for instance, you can have sodium plus as a cation and chloride minus as an anion. This is an ionic compound, right? And if you were to dissolve those in water, you would get sodium plus and chloride minus away from each other. Well, in acid-base reactions, we kind of have the same thing that happens, because let's say that you have acetic acid plus sodium hydroxide. Okay, in this case, the sodium is the positively charged cation, and the hydroxide ion is the negatively charged anion that's also basic. So whenever the hydroxide takes this proton, and the electrons go back to the oxygen, you end up getting the acetate anion that now has a sodium counterion, because the positive charge of sodium is going to be attracted to the negative charge of the acetate, which is the name for this type of acid here. Vinegar is acetic acid, so that's where it's a way that we have interacted with acetic acid before. And then we also have H2O that is made in this reaction. And it's neutral. So if you notice, we started with a salt, a positive and minus charge, and we ended with a positive and minus charge. And those are the two counterions we have here. And that's essentially all that is covered in section 3.8.